Everyone, welcome to the linear algebra to algebra tutorial number 1. So for this tutorial, we'll be learning how to use Gaussian method to find the solutions of the systems of linear equations. So now for this case, we are given like systems of linear equations to solve. So now let's try it for two unknowns, which is x and y. So we are given a system of two linear equations. So now, what do we do? As we have learned, so we are given with 2x and x. So what we do? We swap the row 1 with row 2. Why do we swap row 1 with row 2? Because we will want to eliminate we will want to eliminate the x unknown for the second row. So what we do, we swap the row 1 with row 2, and as we are given as this. From here, we transform to this. So now, after this, what do we do next? We eliminate the x unknown in the second equation. So this is what we did. Second step, we add minus 2 times of row 1 to row 2. So as you can see, the first row still remains, but the second row will be changed. So this is how it works. So for the left hand side, minus 2 times the bracket of x minus y plus 2x plus 3y will give you this 5y on the left hand side. For the right hand side, minus 2 for this, and then plus 13 will give you 15. So this will be the right hand side. Hence, our second row will turn out to be as this, 5y plus 15. So now we can find the value of each variable. From row 2, it shows that y equals to 3. Plugging it into row 1 will give x equals to 2. So now we are going to work on a system of 3 linear equations with 3 unknowns. We have x, y, and z unknown. So first thing, what do? We have 3 unknowns, but first we work on the x, 3x, and x. What do we do first? So we swap. So like the higher coefficient will go to the bottom. So like since 3 is a higher coefficient, we shift 3 to the bottom. The 3x, so we go to the bottom equation. So we swap row 2 with row 3. Hence, we will come up with this equation. From here, we transform to this first. We swap the row 2 with row 3. And now what do we do next? So now we add, so we want to eliminate the x unknown first for the row 2 and row 3. So from this row 2 and row 3, so we add row 1 to row 2 to eliminate the x unknown in row 2, and then we add minus 3 times of row 1 to row 3 to eliminate the x unknown in row 3. So this is how it works when I add row 1 to row 2. So x minus z minus x plus y plus z will give me y. So for the left hand side, it will be y, and the right hand side will be 0 plus 4 equals to 4. And now for my adding of minus 3 times for row 1 to row 3, what did I do? For my left hand side is minus 3 bracket x minus z plus 3x plus y will give me 3z plus y on the left hand side. On the right hand side, it will just be 1. So hence, I will get an equation like this. From here, we transform to here. But now, we are left with the y unknown on both rows. So we want to eliminate the y unknown in one of the rows, which is the bottom row. So what do? We add minus 1 times row 2 to row 3. So as it says that for this one, the left hand side will be minus y plus y plus 3z equals to 3z. So for my right hand side, it will be minus 4 plus 1 will give me minus 3. So hence, this will be my transform equation. So now we can find the value of each variable. So from row 3, it shows that z equals to minus 1. From row 2, it shows that y equals to 4. So I plug these two variables into row 1, it will give me x equals to minus 1. So now, as a whole, why do we swap the equations first? So that we can actually compare and we can actually bring the lower coefficient of the unknown in the upper row so that we can easily do our elimination of the unknown variables after that. And now for adding rows to rows, why do we do this? So that we can eliminate a similar unknown in the other row. Like in this case equation, we have two unknowns for the x, two similar variables or unknowns, which is x. So we want to eliminate to get it like in this kind of situation so that we can solve it easily. Same as this, like we have x and x and x, so we slowly want to eliminate the x unknowns in the bottom two row so that we only have x unknown in the first row. So we do this, and now we also want to keep adding the row for the row 2 and 3 so that we can get only the y variable in one row and the z variable in another row, and we can get it in a form that we can solve easily. So if you have any questions, feel free to drop me a comment and I'll get back to you. And for our next lesson, we will be using Gaussian method to solve a system which might not have a unique solution. In that case, they might have infinitely many solutions or no solutions at all.